All right, short video here. This is our last part of this chapter. Note we went through L in our outline here. This was a long chapter, it's a beast. Let's finish it up. A real short, quick video here. Tosylates. Okay. Remember para-toluene sulfonic acid, a benzene ring, a phenyl ring with a methyl on this side, that's toluene, and an SO3 group over here. It's a strong acid. It can be used just like H2SO4. We have the abbreviation TSOH. It turns out that if we look at this group here, if we took off the OH, because this SO3H is just sulfur with two oxygens and an OH on it, if you took off this OH, this group is called tosyl. CH3, benzene ring, S double bond O is called the tosyl group. If we just took off the hydrogen, then there would still be this oxygen on here. This is tosylate. The sulfur having three oxygens on it is the tosylate, OTS. That's a good leaving group. Recall we said it can't be a nucleophile. It's the conjugate base of para-toluene sulfonic acid, that's what tosylate is, and it cannot be a good nucleophile, which means it's a really good leaving group. Turns out there is a nice way, some folks like it, of turning an alcohol. Recall OH minus, poor leaving group. We've been making it a good leaving group by protonating it. That's one thing you could do. We've made it a good leaving group by turning it into an alkyl bromide with PBr3 or alkyl chloride with SOCl2 and pyridine. You can also make it a tosylate. You can add tosyl chloride. Here's our, looks like para-toluene sulfonic acid, but instead of an OH, you have a Cl. You just buy this stuff. Buy your tosyl chloride, and if you react an alcohol with tosyl chloride, you get this beast here. It's protonated, but you add a little pyridine base, and then you get our alkyl group, the CH3H, CH2, CH3 right here, bonded to the oxygen, bonded to this, and this is an alkyl tosylate, which means this beast here, from this oxygen to the methyl, this is the tosylate group. That's a good leaving group. So if you did that reaction, instead of making it a chloride, you can run, if it's a very good leaving group, now you can run SN2 and E2 reactions with strong bases. Note, you probably don't want to acidify this, because if you ran it under acidic conditions, SN1, E1 conditions, you're probably just going to go back to the alcohol. This is a base, so if you add acid to this tosylate, it'll go back to this thing, which will go back to here. So you're going to want to run this under basic conditions, which means SN2, E2 conditions, because basic conditions means strong nucleophile conditions. So if you take your alkyl, if you had your alcohol, added tosyl chloride and pyridine, you'd make this tosylate. Then you could just run it, react it with OCH3 minus methoxide to make the ether VSN2. If you used a strong sterically hindered base, such as tert butoxide here, you will get the E2 reaction. And that does it for this chapter. Yay.